super excited to talk about exterior motorized shading today. Anybody who knows me knows that's a subject that I've always been drawn to, and I've stressed, as Ken pointed out earlier, early on in my career and at Passive House events, that power is nothing without control. And so we need to concern ourselves with making sure that we fenestrate and shade responsibly when we do passive house projects. And as you'll learn today, it's not just about passive house. There's many other reasons why you want to do this, but again, welcome. I'm very happy to have partners here with me today from Loxone and from 475. So we're going to divide and conquer a little bit in terms of the product itself, the integration of the product, and the control of the product. So that's what you can expect from today's track. And I'm going to hand it over to Floris to kick us off. So Floris, here you go.
Yes, Tim, thank you for that introduction, and Ken. I'm happy to be here with Igor. Yeah, why exterior shading? Well, this is actually allowing us to optimize the buildings. So Tim, can we go to the next slide? It helps with our comfort or prevents our discomfort. But of course, we need some control for that. As you can see here in the bottom, of course, throughout the seasons, as we all know through our passive house training, the sun angle changes. And so in the winter, we can get very deep sun into our south-facing windows. While in the summer, we can get a lot of shading of that, of fixed objects. Unfortunately, not all of our windows are facing due south, as in this Hudson Passive House project, the first certified project in the state of New York. So, as you see me sitting here under a really big lamelux skylight, if you don't have exterior shading, you might have to have some interior shading on your head to avoid some glare on your face. So that's discomfort, correct? So this is something we want to avoid. And if you do that on the outside, we also keep the heat out, the glare out, can help with privacy. And of course, interior exterior shade will work both just as well for privacy. But the sun moves, it's dynamic. So how can we actively manage it to help our passive house envelope? So why don't we do this on the inside? Well, if we do this on the inside, as you see here on the right side, the heat's already in the building. If the heat's already in the building in the summer, it's not as effective as doing it on the outside. If you don't get any direct sun, we cut out a large part of the solar heat gains. There's a little bit of diffuse solar heat gains or reflected solar heat gains, but if you get the direct sun out of the building, this makes a big difference. The glazing is also, on if you know the glazing IGU nomenclature, on the surface 2 and 4, there's normally the low E coatings in the triple pane. It helps tremendously with improving the U values of the IGU, but it also means that the heat stays in the building, which is very nice when you want it to, but it's not so nice when it's already in there. And then it's in between your curtain, the interior curtain and the glass. It will most likely end up on the inside. And as Nick Grant shows here, go back one. Summer comfort isn't just about air temperature. We've learned about, radiant discomfort, which can be cold radiant discomfort, but it also can be hot radiant discomfort in the summer. So move away from the hot glass. So, if we, again, shade our glass, the glass will be colder, which also will prevent radiant discomfort. Next slide. So how do we apply this? How can we use our shades? Well, the benefits of exterior shading are universally applicable. Not just a passive house. Any building can benefit of this. It can be found on all building types in a variety of climate zones. Offices, schools, housing, even the old factories, the shed roof on the old factories provided, and artist studios provided northern light. So you get the daylight without the heat. Unfortunately, no heat in the winter, but also no heat in the summer. So critical in a passive house where we actually want to employ the high solar heat gain in the winter with low sun angle, so it actually shines into the building. But if we have cooling, now we need to keep it out at the same time. Of course, our deciduous trees can help with this, as shown here. But we also can automate this with exterior shading systems. Next slide. So here we see what the PHPP actually, as a ground rule, shows this effect of interior shades versus exterior shades. So exterior slats keep 94% of the heat out. And that's on top of the solar heat gain factor of the glass, right? So if the solar heat gain factor of the glass is 50%, it blocks 50%, and then we knock it down another 94%, to 0.06. If you do it on the interior, you only get 30% of that solar heat gain blocked. And then, Tim, you want to expand on this, for how you enter this?
I'll feed in exactly. So a little bit from the practitioner's desk here on top of that, as far as controls go, which is another subject we're bringing to you here today. So once you have exterior shades, it's all about what are you going to do with them? Are they static? Are they being controlled? Are they manually being controlled? Are they automated? And Passive House Institute has looked at that as well. And I can't sort of explain to you exactly why they came up with the numbers that they do, but we did print them on this slide here for you for your reference. So in the PHPP, it is assumed that you'll have a 70% reduction when it's manually operated exterior shades, an 80% reduction when it's automated. And for the overheating potential of the building, the PHPP assumes 90%. So I assume we could argue with the PHI whether these are fair numbers that represent these use cases, but it's just something that you need to keep in mind when you're modeling exterior shading. Everything that Flores said is of course true. You're potentially, if you keep the shade closed, you're knocking down 94% of the solar heat gains that hit a window. But in reality, it's not just going to stay closed, right? So it'll either be manually operated, automated, or in the case of the PHPP, it even has sort of a best case scenario when it models the overheating potential of the building. So just keep that in mind. These are going to be factors that you're going to find in the PHPP. And that's what the PHI says are realistic use cases. I would add to that, you know, from living with shades, you can see that perhaps over my shoulder, you know, in reality, even if you have an automation system, you may still use manual controls from time to time and do overrides. So I couldn't necessarily tell you how good these percentage numbers are that the PHI provide, but I can tell you from having done projects that are entirely manually controlled, that obviously is never as good as having an automation system. So if the owners aren't home, the shades aren't being controlled, so they may stay up or may stay down, which means something. I live with a system that is fully automated, but we still as a family override that system from time to time. So just keep that in mind when you're modeling shading in the PHPP.
Yeah, so then if we look at the building code, you can see that actually the building code, of course, is puts a very low bar and makes a simplification. So we can see that in the heating dominated climate zones 4 through 8, we are, you know, the solar heat gains are actually free to choose in 4, 5, 6, and 7, and 8. But then in 4, so it's marine 4, it's free to choose. But then in the other 1 through 4, we are actually limited to the amount of solar heat we're allowed in, which is especially in 4, it's still a very much heating dominated climate. Of course, we want to also avoid overheating, but there should be the motorized shade should be an option to achieve your summertime comfort and solar heat gain limitation while optimizing your wintertime solar heat gains through your fenestration as well. So you can see here in the bottom that, you know, you can see that we're underheated in the winter, and but in the summer we could be overheated. But there's this shoulder season. So if we have fixed shading, you know, we have excessive shading in March and April. And if we do movable shading, you can see we can really optimize this and actually make the shoulder season longer, so we can actually passively heat the building, but also avoid active cooling in the summer for a longer period of time. So the best of both worlds. Next slide. So here you can see that max solar heat gain values versus motorized shades. So climate zone forest is mixed. It's a heating season that's larger than the cooling season in the figures below, the heating degree days versus the cooling degree days. But in 3C and 3A and B, it gets even more complicated. There's still a good heating load, but there's also a significant cooling load that we want to avoid. Of course, climate zones 5 to 8 are heat driven purely. And you can see that that's why the ratings for the solar heat gain are also not limited in the code. But we still want to keep that, where Tim lives, we still want to keep that summer heat out because there is still a cooling season there, even though the code says there's none, or it doesn't acknowledge it. So in all climates, cooling should be avoided passively first. And we should try with the active blinds or with the passive manual blinds, stretch the shoulder season. That would be the optimum solution. Next slide.
Yeah, all right. So I'll hook into it right here and talk to you a little bit about the system components, what makes up a good shading package. Next slide. So the first thing that we're going to look at here is the motorized shade itself. So most of you are going to be familiar with interior mini blinds, aluminum blinds, and for all intents and purposes, the exterior motorized shade is the larger version of that. So typically they're made from all aluminum, all the components there. And we have slats that articulate in various widths and profiles. I'll talk about that a little bit more in a minute here as well. We have a line voltage motor at the top, and there's no smarts in that motor. Essentially, it gets power and it can turn one way around or the other way around, and that's all it does. As far as the guides go, you get your choice of a fixed track, which is depicted in that image here, but there are also cable guided systems, which look a little bit more free-flowing or floating on a facade. And in some instances where you have exposed corners, glass corners that you want to shade, that's perhaps the more appropriate way of guiding the slats themselves. They can be mounted either on the exterior of the building in a recessed fashion where they're either flush with a building facade or they stick out a little bit, or they can be fully integrated into the building where essentially when they're up, you don't see them at all. There's a variety of colors available. Most of these manufacturers have a color palette of about a dozen or so standard colors, which we always advise our clients to go for in case they ever need a replacement part. But in principle, most of the firms that offer the product will stick to the RAL color system, which some of you may know from the Passive House window offering, which generally adheres to that as well, which offers quite a variety, and you can order from that catalog as well. And when you're designing a system like this, your key considerations are, architecturally speaking, how does it look, of course, but then things like wind resistance and the shading factor. And that we're going to do a little bit deeper dive into that because that's where some of the products under the hood sort of differ from one another. Just quickly here, so the graphic that's next to the picture of the system is a section cut through it. And so this is going to be key, especially when you want to integrate the system to understand, how tall is what they call the slat stack height. So essentially the system, when it's completely up, how wide and how long of a shade box do I need in the building to get this integrated and or attached to my building. Next slide. So let's talk about the slats first. So the considerations here are coverage and wind resistance, and also maybe I should have added here how well they capture the sun or the sun's light for room darkening. We have from left to right in the graphics here sort of simple slats, and then from there we can advance to shapes that are a little bit more expressive, and that's not just for design, that is for particular reason. So by folding the metal and hemming over the leading edges, the slats can be made more durable, more wind resistive, and also keep more of the sun's light out. You can imagine when these close, the one on the left, which is really just a piece of aluminum, it's not going to close very tightly. the slats don't really support each other very much when they're in a closed position, whereas these S-shaped or Z-shaped slats that you see there, they almost hook into one another. They can almost have like a little gasket on them where they really close very tightly. And so where this manifests itself then is, going back to my notes here, the simple slats really don't have any significant wind rating. No, they're not going to fall apart every time the wind blows a little bit at them. I think it's fair to assume that they are safe outside, you know, for winds up to 30, 35 kilometers an hour. So about 20-mile-an-hour wind gusts. The folded slats, on the other hand, they can go quite a bit further, as you can see here, up to 80 kph, so about 55 miles an hour or thereabouts. They will be safe to be left in the down position. There is a rating system for this for those who want to do a deeper dive, and I listed that here, how that's measured. When you're looking at these slats, they come in various widths. Each manufacturer has sort of their own system there, but generally you can expect them to be somewhere between 60 and 90 millimeters thereabouts. So 2.5 to 3 5/8 inches is about the typical width of a slat. And that has everything to do then with coverage, you know, the stack height that I talked about before. So in other words, if you have a thinner slat or less deep slat, you're going to need more of those to cover the same surface as having a wider one. And that has something to do with your packet height or stack height when they ride up. So those are all things you want to look at when you're selecting a system. Typically, you can cover up to 6 meters or about 20 feet in height with one package, and about 20 square meters or about 200 thereabouts square feet out of one system. And again, the lighter duty, smaller slats will probably go less of a distance here, and the bigger ones might be able to cover a larger surface just because they're more stout. So again, want to point out this term of the slat stack height. One of our vendors calls it that, which is, especially in an integrated design, is really what you're looking for. How tall is that package when they're all the way up? Next slide. So then let's talk about the shade box. So that's essentially the container that the slides ride into when they're not being used. And this can be purchased. This can be something that is made, or it can be a mixture thereof. It can be integrated into the building. It can stick out a little bit. It can be bolted to the face of the building. So thereby it can be an invisible element where you don't really call any attention to it, or it can be decorative. It can be a statement. It can be something you integrate into your design language. The size of the shade box needs to be sized exactly to fit the shade system. So this requires a little bit of integrated planning. And what I didn't note here, but what I'll tell you is that there's, of course, also a relationship between each window and the size of the shade that you put on it. So one of the things that we found over the many years that we've integrated these into projects is that it makes a lot of sense to source these as one package with the windows that you're purchasing, just to make sure that there is good and tight coordination between the window sizing and the shade sizing, making sure that they work well together. And in some cases, the shade system may actually be affixed to the window itself. I don't want to go too deep on that today, but short of bolting it to the building, it can also become part of a window or storefront or curtain wall system, which would suggest an even tighter integration when you're sourcing this. Next slide. No picture here, but I just want to mention, you know, obviously we're talking about new construction here, especially for the integration, but this is all applicable to retrofits just the same. So the integration is more likely in a new construction, the exterior bolt up more likely in a retrofit like an interfit. And that has something to do with how you might want to control it as well. Igor is going to talk a little bit about different versions of this, but in a new construction, you have all kinds of opportunities to integrate this into building controls, hardwired, whereas in a retrofit application, you may be more prone to go to a wireless system or something like that, where really all you need to bring to each shade location is just line voltage. Next slide. So then I'll talk about the integrated shade box. So this is the building that I'm standing in right now here, a house I built a few years ago. And just a couple of pictures of an integration of a shade system. So my house is a double stud wall, all wood frame construction. And in these pictures from left to right, you can see how that exterior TJI or floor truss wall that we built, the secondary cavity, we created voids above each window with that exterior framing. And then those voids were filled with a site-built shade box that we made. So the picture in the middle shows you that cavity. And then in the third image here on the right-hand side, you can see that cavity filled with the shade box that we made. And in this particular case, we actually integrated into the shade box exterior over insulation for the window frame. So the backside of the shade box was made from a wood fiber board material that acts as additional insulation for the window in that particular spot. You can see the pigtail for the power cable being, brought to daylight here, which later connect to the shade. Next slide. So this sort of an idea, as I mentioned, requires integrated design. The detailing here is key for the aesthetics, the performance, and the durability of something like that. And as I pointed out, close collaboration with the window and shade vendor to make sure this fits. So typically when we go into the shop drawing phase for a project like this, we will send this to the window company, we will send it to the shade supplier and make sure that all of those things coordinate well with the architectural drawings and concept. Next slide. So here we can just bounce through it, Igor, real quick. You can see what happens when the button is pushed and they come down. So you don't see them at all at first, and then they start to ride down. Keep going. All the way shut. So this is like a night mode or privacy mode. Keep going. And here you can see them in a shading position. So this is essentially what happens if they're all horizontal. Now, in reality, what happens in my building is that you will see them at this state at various times of the day to keep the sun's heat out mostly, and then they will articulate. Igor will talk more about that. But one of the benefits of the motorized shade is that it doesn't just have these fixed states. You can have it articulate in sort of 15-degree increments. So between fully closed and fully open, there's a plethora of little steps that it can take. And with some building automation, it can actually track where the sun is and adjust the shade accordingly. And one of the benefits that I tap with this system is that I favor daylight while still cutting the heat gain when I don't want it. So the opportunity here is that you reflect the daylight into the space so that the space is well lit during the day, but you cut just enough sun so that the direct heat does not penetrate the space. And as Floris pointed out, in a passive house, in a cold climate, like I'm in climate zone 6 here in the US, you really want to manage that. We have tremendously low sun angles, especially on the east and west sides, where this becomes an absolute must not to cook people out of those spaces. But on the south side, in the swing seasons, this becomes really, really important as well. This morning, I woke up to about 26 degrees Fahrenheit outside. The sun is out, it's clear blue sky. If I don't use my shading system today, I'll easily heat the house up into the 80s. And that's not desirable. So it's nice to get the free heat in the passive house, and that's part of the concept. But again, power is nothing without control, hence the system. Next slide. So exterior shade box, just a quick static image here of an office building we retrofit some years ago. You can see, it's actually pretty subtle. Those silver shade boxes, and actually the red window has a shade as well, and that's a color coordination there where the siding and the shade box are fully coordinated, and the track is as well. So this would be a totally exterior retrofit application. With this building, this was retrofit to the interior. Pigtail was stuck out for the power, and all shades are controlled wirelessly, and they're self-supporting in these boxes, bolted up to the exterior of the building. Wanted to show you an example of that. Next slide. And then I'll talk in principle about the components that you need to control this, and then let Igor give you the more detailed overview. So the first piece of the puzzle, once you put power to a system, is you need what we would call an actuator. You need some kind of a device that tells the shade, what to do. Not so much the intelligence, but like the communication, right? So you go up, you go down, you tilt a little bit one way or another. And an actuator can be wired, it can be wireless. And in the most simple case, this can be an up-down switch, right? It could be a user inside the building just going up, going down, and doing this manually. This is one of Loxone's products here that's a wireless component that can do that for you. I will also say, I don't think we mentioned it before, that prior to the motorized systems, there were manually operated systems, often used with a hand crank, and maybe Igor will talk about that a little bit. The reason why we're not bringing those into the picture here is because they penetrate the airtight building, and that's not something that we want. There's also a thermal bridge when you have a manual control from the interior, that is. So we're looking for something on the outside and that can do the work for us, and we call that the actuator. Next slide. Then if you're going down the route of automation, now you can branch out into devices that can understand where you are on the planet. They can track the sun, they can track the climate inside, outside, the sun's position, as I said, from a daylighting perspective, as much as a heating position. That can be a small little server like this. Again, I'll let Igor expand on that. So that's the next step. And then the last step of componentry that you need for a system is some kind of protection. So I want to be very clear here. These types of motorized shades we're talking about are not like the hurricane shutters in Florida. So these are not to be brought down to protect your windows from damage when you get storms. They are purely here for all the benefits that Flores brought to you: privacy, sun, heat, all of those things. And so they need to be protected. And the two things you want to protect them from is high winds, as we already talked about a little bit. And the other piece is frost. And that pertains to certain climate zones in the country like mine, especially in the swing seasons, early and late winter, where we may have conditions that are conducive to icing the shades over. You can imagine if a lot of ice accumulates on them, it becomes more difficult for them to move up and down or open and close. And so a protection mechanism for frost conditions is also desirable. Next slide. With that, I hand it over to Igor.
Hi, everybody. I want to talk about the automation aspect of the shading from a standpoint that Tim and I discussed. It's a must for passive homes, cooling, heating, and I want to discuss why. So shading, what it used to be, as Tim mentioned, an out penetration through the wall with a control, manual control. So whenever you had to adjust the shades, you would have to manually raise them and adjust them. It had no intelligence. You had to do it by hand, and again, protrusions through the airtight layer of your home. Then came the smart control, which people call smart. I wouldn't necessarily call smart. It was just control which you can control without manual operation. You could press a button, or you can create scenes in the app where the shades would go up and down. And where Loxone comes in is not only control but automation. And what we have designed in the system is something that you don't have to think about control. You don't have to think about controlling the system yourself, because to make it 100% smart, you would have to basically control them yourselves every time the sun changes position, the temperature changes. If you need to protect them from frost or high winds, you have to do it manually. So you would have to basically be in your home and have to run around and close the shades, open the shades to have them effectively cool or heat the house throughout the day. So why? Exactly, because nobody can spend the whole day inside the house and just think about shading, check what the weather is going to be like, check what the wind is where the sun is coming from, what time of day, and where's the sun shining from which angle of the house. So we have a wide variety of products that can help you automate it. So it starts with the brain, with a mini server. In the top left corner, you'll see two examples of our Loxone mini servers. The one with the red contacts in the bottom that has relays that can control shading, and the one down below, which is does not have relays. It has the same exact brains as the bigger one. It just does not have all the same inputs and outputs. Then we have different style of actuators. In Europe, we actually have shading motors, but unfortunately, we do not have them in the United States yet. Hopefully, as passive homes grow, we can get them in United States as well. But we have other ways to bring the shades up and down and tilt as needed. Different actuators for different systems. But actuators are not the only component of the system. We have presence and brightness sensors for rooms. So if you do want to increase the effect of having a light in the room and have that favored over the shading, you can have presence sensors that have brightness sensors in them, which will bring your room to the light comfort that you want. We have also the weather station, as Tim mentioned. It's a very important part of shading, especially exterior shading, because you want to know how much radiation you're getting, wind speed, and temperature, which is very important at the location, because once if you have a high dew point and low temperatures, you can get frost on your shades and damage your shades if you operate them. So our weather station has those sensors built in, which can help you automate it. You don't have to think about, is it safe or not safe to bring my shades up and down. Also, our switches, as you see on the bottom, the white and anthracite one is on the bottom. They can control your shading. Also, they have built-in temperature sensors, so that your room knows the temperature you're in. You don't need to buy other equipment to measure. The switches have that built in. If you need, unfortunately, sometimes what happens with shading and sunlight is sometimes the switch is exposed to direct sunlight, and you can skew your temperature. That's where we have comfort sensors, which can be strategically located in a room, so you don't your temperature is not affected by the direct sunlight on the switch. As I said, there's multiple wiring options for shading. The most I think maybe not common, but the most recommended centrally wired blinds to relays. This is where you would have relays inside your panel, a low voltage panel, where you can switch your shading motors. Usually it's one relay for up and one for down. As you can see in this picture, the mini server has 8 relays, so they're used for, they can be used for shading. And if that's not enough, we have relay extensions, which can be added as you need it to your system to control the shades. And again, not only shades, lighting, and other aspects of your home. This is another option. This is decentralized. With our Nano 2 relays, you can have power going directly to each shading location and just have intercommunication back to the mini server. And the mini server will communicate with these relays to control the shade actuation. These Nano 2 relays have 2 contactors per per relay, so you can control up and down with one device. And what Tim has in his home is the wireless shading actuators, so they communicate with our mini server over a radio frequency. We call these devices air devices, and they not only communicate back to the mini server, they also create a mesh network, so you don't have to worry as much as spreading the signal. But depending on the distances, you may need to add other air devices, such as tree-to-air bridge, closer to these shading actuators to keep the transmission levels at a normal level. Okay, so I said automatic shading is where it's at. What we have in our system is we have the ability to know where the home is, where the sun is in position to the home, where the windows are in position of the home, and control the system based on that. So we have pre-designed blocks for shading, and they have been worked on and improved since the system has been come out. The Loxone was born in Austria, and as you know, that European shading is very important. So this automation has been worked on very heavily to optimize the way the system behaves with shading. So we have automatic shading blocks in our programming, which help you automate the system with the input that you give it to the system. You also can visualize it in the app. You can any smartphone, any tablet can be a point of control, not just the wall switches. And we can work with different shading types. Of course, we're talking about the outside passive house shading, but with awnings, with roller blinds, and so on, we can put these put the type of system it is into the Loxone config, and it will help you automate and will give you the best benefit to the system. The other part is our automatic shading blocks are integrate with the heating function blocks. So the room that's calling for heating or cooling will utilize the shading first. So you're gonna save or use the energy or save the energy by optimizing that. You know what temperature the room is, you know where your comfort levels are, and the shading will adjust because it's communicating with the heating and cooling aspects of your home. And as also the storm and frost protection are built in, so we know the system knows what the speed of the wind is, and you can automatically set at what speed of the wind or gust of the wind you would like to bring your shades up to protect it. Again, it depends on the manufacturer specifications of the shades. Different shades have different wind tolerances. Okay, so wanted to discuss really quick what inputs we have in our automatic shading blocks that help control the shading. So for control, we have, as I said, our touch. We can connect to our heating and cooling of the room. We can also door window contacts if we have if you need to open the window you can have that the shades go up if the door and window contact is open. So in case you are using your shades for in front of you, your big patio doors, the second you slide your patio door open, your shades can go up because you have a door and window contact, letting know that the door is open. Something again we touched upon is the storm and frost protections. So what is included in our the weather station, and it comes in two varieties. One communicates over radio, air, as we say it, and one communicates tree back to the Loxone mini server. The sensor can give you the wind speed, the current brightness and lux, and why we need that is because if there's no sun, there's no reason, there may not be a reason to shade. Temperature, and also a rain sensor. And what the rain sensor is also used for is to know if we got rain and the temperature falls below a certain point, that's when we activate the frost protection. With the weather station, with the purchase of weather station in Loxone, you also get the weather service, which is when you get internet information about the upcoming weather. So you can automate that. You know that the outside temperature is going to increase in the near during the day. So you may want to start shading earlier, or if you know that temperature through the day is going to increase, so you may want to open the shades to get most of the light energy as you can. So it's in our system, it's the automatic functionalities are that automatic. It's very easy to program in our system. It's basically a click of a button, and the system builds these blocks depending on your what hardware you have and what functionalities you want. Of course, after that, you can adjust, as Tim has done many times, to maximize the level of comfort of the system. The technical parameters for the best shading and to have the best shading correction functions. So for that, we need the window orientation. As I said, where's the window pointing? Our system knows that if the window's pointing west and you're at a certain geographical location, when that sun will enter your window, should enter your window. The room temperature, because you need to know if the room needs cooling or heating with shading. Outdoor radiation, as I said, our weather station can tell us if there is sunlight to warm the room. And the weather station is I would say a must, because if you don't have, even if you have the weather service, you may not be falling into that category. If the weather service is telling you, yeah, there's 40% chance of sun, you may have sun and you may not. So you need to know that at your given location. Times of the up and down for the shading. As Tim said, the system is when the shades are built, they're built for the length of the window. So you need to put in these factors so the system knows how much time it takes it to close and to open the shades, types of shading. So the other important things in environmental influences, such as do you have something that's blocking this window, and shading is not important at certain times of day. The distance between the slats and the width of the slats is also important, because the angle may change at which you are getting sun into the building. And of course the room type, because some rooms, sleeping rooms and living rooms, you may want the effect of automatic shading to be different. Such as in living rooms, you want more light. In sleeping rooms, you want more privacy. Seasons are, of course, the system automatically knows if it's what season it is. Alarm, this is an interesting one. So the we try to, Loxone tries to bring all of the components together so the building works together. So if you have an alarm, somebody breaks into your home, you have a fire, the shades will automatically raise up, lights will automatically turn on, and that's done. If for burglary, if somebody breaks in, this is to expose them, expose the burglar. If it's a fire, it's so people can get in safely. I can see what's going on inside the building. And these are some of the parameters. As you can see, there's a lot of parameters to enter, but the more accurate you are with the parameters, such as degree towards position of the windows and the slat distances and slat width, the better the system can work together. So the direction of the sun is important, so we know from where it rises and where it falls. That's important. As I said, the obtrusions, and this is the exact time when the sun starts radiating into the window. So you may have things like buildings or trees that are blocking, and that needs to be input into the system to get the accurate shading. And then the other factor is, when is it truly radiating? There's a lot of factors. I'm not going to go into all of the detail because it's then I'll start teaching you how to program the Loxone system. So this is a chart that shows the very important thing that we want to minimize how much time the house heats and cools using traditional methods. We want not shading. So in the dark red, this is when your heating would be, and the dark bottom red line is the comfort temperature for heating, and the top blue line is a comfort temperature for cooling. So we want to maximize the dotted line for passive heating and cooling, and that's what automatic shading can do. Okay, I think, and again, as Tim has mentioned, this is not only for heating and cooling. The security in the Loxone system, overheating protection of the rooms, flexible grouping so you can raise and lower all your shades at the same time. Storm protection, that's protection of the actual shades, not protection of the building. Privacy and frost protection. And Tim, I'll hand it back over to you.
Thank you, Igor. Much appreciated. So hopefully your takeaway is that you can go very deep on the programming once you have a backbone like that in a building. But I will also say this from both a practitioner and a user of a system like that, from that perspective, and that is that you don't have to understand all that or populate all of that. A lot of it will happen automatically and will be very responsive. I think what we're seeing there, what Igor brought to you, is that you can really go deep and fine tune the system tremendously. And so I've seen systems that are very basic in setup and they work wonderfully. And I've seen systems that are very detailed in their settings and they also work wonderfully. And you may find for your project or your building, the truth is somewhere in the middle. The important part is that with the automation system, you can get all these benefits as pointed out. Let's jump to the next slide. I want to close you out here. We're getting close to the hour, and Ken is having some technical difficulties, so I'll try to fill in for him with a Q&A. But before we get there, this is a question I often get from clients, as far as maintenance goes. What's the maintenance? Maybe before I talk about the cleaning here, I'll also tell you that I've worked with systems like this here in North America since 2008. We have never had one break or fail yet. So they are fairly resilient. And as Igor pointed out, in Europe, they've been using this longer than we have. And you see it on many, many buildings of all types. And so the manufacturers have a lot of experience with making this product resilient and durable. And we've really seen that. They do well in our markets here as well. But when it comes to cleaning, I've had people ask me that question. They, like anything, like your window too, every once in a while you should and you want to clean these systems. And here's just a couple of pictures that show you how you can do that yourself. So if we're talking about a single family home, these are the most appropriate ways to do it. I mean, short of just taking a rag and wiping them down, there's a hose attachment that you can use. You can also order online these sort of specialty formed rags, like the thing on the right-hand side, so that help you basically swipe across these units. And then Igor, let's skip to the next one. Next slide.
Yep. Oh,
there we go. Oh, yeah, one back. There we go. So if you think larger, because we sometimes talk about homes a lot, but obviously you can bolt this up to any type of building, and these are used commercially the world over as well. So when you get to that level, the care, the maintenance, and the cleaning also grows with it. So here's just an image of a professional cleaning service and cleaning piece of equipment that hooks up into a pressure washer, where you just make speed when you clean these things. So there is an ecosystem, and I think that's maybe one of the key thoughts that I want to leave with you here today. There's an ecosystem around these, from planning to implementation to controls to the care and maintenance. It's fledgling in the US, but it's here. And again, in a global, if you think globally but built locally, there's many resources available for a product like this. And so with that, let's segue into the Q&A section. Next slide, Igor. Thank you.
Yep. Mm-hmm.
Yep. And so thank you for your questions. I see them in the chat here. So I assume Ken hasn't been able to get back in. So I'll just go through this here, and we'll see how we can answer those for you. The first question I got here is from Vlad. He's asking, will the Warema exterior shading systems be available through 475? Floris, you there?
Yes, I'm here. Yeah, so we supply both for Optiwin and for Lamalex exterior shading systems that matches with those systems very well. But it's kind of a group deal, so we don't do the shades by themselves, because that's really also inefficient to ship in that sense. So that's why that's the way we are able to bring exterior shading systems into the North American market that can be then be integrated with automatic systems like the Loxone.
Right. Well, thank you. The next question here I see from Sam is something to do with whether there's any incentive programs. He's talking about an example from Vienna where the government pays landlords to install solar shading, and whether we're aware as a group here of any incentive systems, city or state in the US that are out there for these types of systems. I'll just start from my perspective. I'm not aware of that. As you all probably know, this is a fledgling thing yet in the United States. It's a very powerful tool. I think it's a very useful tool that you can use with any type of building and provide the benefits that we've shown you today. But as Floris pointed out, there's even a sort of a clash between building codes and a product like this in certain climate zones where it's not even taken into consideration if you have this on the building. So I think we're just at the beginning of that journey here in North America, at least from my vantage point. I don't know if the two of you, Floris or Igor, have seen anything else.
We know that both in various states, like the Building of Excellence program in New York, in Massachusetts, their incentives, as well as, for instance, in the rebuilding for the fires in Boulder County in Colorado, there is specific incentives for passive house, where of course certified passive houses get quite some funding. And then, of course, this argumentation would be that if the PHVP would, or the movie passive will show that this works, this is allowed, and it should actually override the code. So that's yeah, that's very you know, a little bit of civil disobedience, or actually smart engineering. Smart engineering should and is allowed. So and should be pursued.
Excellent. The next question I see here is from Michael, and he's wondering if there's any system like this that would, you know, work in Florida with hurricane force winds. And at least from my experience, Michael, unfortunately not. It's quite the opposite, as we've shown you. After the 55-mile marker, you do want these systems to retract. That's not to say that you couldn't use them in Florida, because obviously you don't have hurricanes, you know, all the time. So if properly installed, you know, they would then literally ride up and protect themselves in an extreme weather event like that. And that's really no different than, well, slightly different maybe, but we see straight line winds and tornadoes where I live, and we certainly get gusts sometimes that are, you know, in excess of these wind speeds. And so that's just a matter of protecting the product. But that means, you know, still 99% of the time when you're not under extreme weather conditions, that this can still do a fantastic job and provide all the benefits that we've shown you today.
Hey, Tim, I'd like to chime in. I've seen systems in Europe, automatic systems that are built into the actual window. I don't know if that is available, but I know between the two double pane glasses, there's electric shades that are built into the window.
Yeah, that's fair. And I've seen that as well. And there's probably manufacturers who do that in a triple pane glazing unit as well. Mm-hmm. I think the benefit is just slightly different. And I don't know exactly where Michael was going with that, but I think that they're never protecting the glass, I suppose, is, you know, while they may still work in that, they're just not, their job is not to protect the glass from debris or something like that. And I just want to be very clear about that here as well. All right, so we're a little bit over, but I think as long as you guys have stamina, I'll go through a couple more questions here before I close it out. And if some of you have to drop off, thank you for joining us today. But I'll try to answer a couple more questions because I think they're really good questions here. Thomas asked, you know, how do you mitigate the rattling of the slats in the wind? And that the answer to that is very simple. It's built into the wind protected versions of the slats. So you just have to make sure when you're ordering the system that you're specifying the right slats. So there are, as I showed you in the very beginning, there's some very basic systems, and they're lighter duty and they're probably cheaper too. And they may rattle a little bit in wind conditions, and there's others that reach into each other and lock each other in, and there you get more protection from that. So that's a spec question. Let's see what else we have here. Are there wind sensors? Kevin asks, are there wind sensors that would automatically raise the shades if the wind gets over so many miles per hour? And Igor, you could say this or I can, but yes.
Yes.
That's the point of automating it. So you don't have to sit there and measure the wind and tell it to do that. Absolutely. David asks, looks like each shade needs 110 volts, not low voltage. And that is also correct. These are line voltage motors. Where the line voltage comes into play is in the control systems. And that, again, depends on whether you have a hardwired system or, as Igor pointed out, an air-based or a wireless system. Sometimes you have hybrids of those two. So the wiring between those components is generally low voltage wiring. But what's correct is that the shades themselves, the motors, they're line voltage motors, and that's what they need. And so you have to think about it in those terms. Copy of the presentation from Alfredo here. I assume that PHN is going to make that available. I will have to defer to Ken. What else do we have? Okay, so Natalie asked the question, do you have to go outside to manually override each window? I guess there was a preceding question. Is wind resistance better with integrated systems as compared to exterior shade box systems? So I'll start with that. So obviously, if they're integrated into the building, when they're up, they're really, really well protected. But I would say that the boxes that they ship with, if it's an exterior application, the shade is still completely sucked into that housing. And so I don't know that there is much of a difference when they're up in terms of wind protection. So up is up as long as you have a box. I wouldn't worry about that too much in terms of that. I don't think there's much of a difference there. So then do you have to go outside to manually override each window? I'm not sure, Natalie, maybe you can explain to us what that meant, but I'm not sure where you're going with that. You can override each window to your heart's content, usually with a local switch, an app control, a remote control, however you want. You don't have to go outside for that, obviously. If it's an integrated control system, you can do that from anywhere, including outside, though. I sometimes, when I give tours of my home, I will be in the backyard with people. They'll look at the exterior of the building and I'll ride them up and down from there with the app to showcase that. So hopefully we captured most of what you wanted to hear from us today. We appreciate your time. And again, I think we've lost Ken. So thank you, Igor. Thank you, Flores. Thanks everybody for attending. Make sure to take a look at the PHN website and all the offerings there. And with that, I'd like to close us out for today. Thank you and make it a good one.
Yeah, thank you, everybody. And let us know if you have any questions. We're always happy to help.
Yes, thank you.